Master and Professor, Department of Mathematics and SNS College of Technology. Today we are going to discuss about the gradient based problem. Okay, so here see the problem. If R vector is given, so R vector is nothing but, so see xi vector plus yj vector plus zk vector, and then such condition is given such that that is modulus of R vector equal to R. Okay, so here the condition is given modulus of R vector equal to only R. We have to prove that the three condition. Okay, so first one is del R divided by R vector divided by R, that is equal to R power k. Okay, second subdivision is instead of R we have to replace 1 by R. The answer is minus R vector divided by R cube. So here he have to replace R vector equal to minus of R cap divided by R square. Okay, then third one is instead of 1 by R we have to replace R power n. The solution is del R n power minus 2 into R vector. Okay, so here first we have to, using this R vector, we have to find first subdivision and second subdivision, third subdivision. Okay, so here see what is R vector. What is R vector is xi vector plus yj vector plus zk vector. So this is our given part. Okay, then we have to find the modulus, that is the modulus of R vector value. So what is the modulus of R vector? You know, R vector is no, we have to find the modulus of R vector. How we can find the modulus of R vector? Is the root of I coefficient the whole square. I coefficient is x, that is coefficient the whole square. Then j coefficient the whole square. Then k vector the coefficient the whole square. So this is the modulus of R square. Okay, so here R equal to root of x square plus y square plus z square. Then we have to find the R square value. So taking square root on both sides. So the answer is R square. So if it is this taking square root on both sides, so here this square and square root is cancelled. We get the answer is x square y square plus z square. Okay, then we have to find the partially differentiate with respect to x and partially differentiate with respect to y and partially differentiate with respect to z. Okay, so here partially differentiate with respect to x, here y partially differentiate y and partially differentiate with respect to z. So first we have to partially differentiate with respect to x. What is that? 2r dou r by dou x. Here also no need to consider y, z, only concentrate x. So that is 2x. Here after simplification this 2 and this 2 get cancelled. I want to find the dou r by dou x. So dou r by dou x value is y. Okay, dou r by dou x value is, that is x by r. So here see x by r. So this is the, okay, so dou r by dou x equal to x by r. Then partially differentiate with respect to, in this equation partially differentiate with respect to y, that is 2r dou r by dou y equal to 2y, that is dou r by dou y equal to y by r. So similarly, what is the dou r by dou z value? What is the dou r by dou z? Yes, it is z by r. Okay, then we have to, using this these values, then we have to find the first one. So what is the first one? Dou, that is del r equal to r vector divided by r. Okay, you know what is del r? So in this previous class we saw gradient. How we can find the gradient value? I vector dou divided by dou x. So phi and phi. So instead of phi we have to replace r. So in this phi we have to replace r. So that is I vector dou r by dou x plus j vector dou r by dou y plus k vector dou r by dou z. Okay, you know dou r by dou x is x by r. So then dou r by dou y is y by r, and dou r by dou z is z by r. So here replace what is that, x by r and y by r, then z by r. So here we see in this denominator is r. Here also denominator is r. Here also the denominator is r. So take it outside. So 1 divided by r. So the remaining is xi vector and yj vector and zk vector. So what is that xi vector and yj vector and zk vector? So the answer is r vector divided by r. So see, r vector divided by r. This is our solution. So in this r vector divided by r, we have to write the r cap. So del r equal to r cap. So in this remaining two subdivision we are going to see next class. Thank you.